Today we have started the cation and the salt analysis. Since we have already discussed the anion which is present in the salt. So in the salt analysis, in this topic, we will discuss about cations. Means how we can identify the cation in a given unknown salt. For example, if we are having a salt of copper sulfate, then obviously no doubt in the salt we are having anion this much means sulfate and the cation is this copper plus 2. But in this topic, we will discuss how we can identify the cation uh, systematically in a given unknown salt. So we will discuss about how we can identify cation. Now we start analysis of cation. And like anion, we will also classify cation and the basic criteria for the classification of cation, we will add up the solubility product that is called KSP. KSP that is called solubility product. It is the basic criteria for the classification of cation. Now on the basis of KSP, we will be classified into following 7 groups. So first we will be classify the first we will discuss about KSP, then we will classify the cation. Now, first we will discuss that what is the meaning of this solubility product KSP. What is the relation of the classification of cation with this KSP? So, for example, we are having a salt like AB, and this is AB, that is A plus and B negative. It is dissolved in a solvent like water or any other solvent. This is the solution of this AB. Now, in this solution, the product of this A plus and B negative ions, that is called ionic product of the solution. So, product of A plus and B negative, that is simply called ionic product. Since it is the product of ions, so that's why it's called the ionic product of the solution. Now we know that solutions are of 3 types on the basis of the concentration of solute. First, we have taken the dilute solution. Dilute solution, a solution in which more solute can be dissolved. That is called dilute solution. And second one is concentrated solution. A solution in which no more solute can be dissolved is called concentrated solution. And third one is super concentrated solution or super saturated solution. Here is not the use of concentrated in place of concentrated solution. Here we are using the saturated solution, and in place of dilute solution, here we are using unsaturated solution. And so we can say that a solution in which more solute can be dissolved is called unsaturated solution, and a solution in which no more solute can be dissolved is called saturated solution. And third one is called super saturated solution. A solution which is obtained after saturated solution is simply called super saturated solution. Now, these solutions will be explained by the help of simple example. For example, if we are taking a container and this container having suppose 100 ml of water, 100 ml of. Now, in the solution, we are adding a sugar. So, initially, we are adding a small amount of sugar. So, we are observed that in the initial state, sugar is easily dissolved in this water. So, this is called unsaturated solution. It means in this solution, the amount of sugar is very less as compared to the solvent H2. So, this type of solution in which we have dissolved more solute is called unsaturated solution. And in the unsaturated solution, the concentration of the ions is called ionic product. Yes. Now, at a fixed temperature and a fixed volume of this solvent, we are adding only sugar continuously. So when we are adding the sugar continuously at a fixed temperature and fixed volume of this H2O, we notice a point or comes a point at which no more solute can be dissolved in this pure solvent H2. So the condition at which no more sugar can be dissolved in this water, that is called saturated solution. Saturated solution. And if once a saturated point comes, then after the saturated point or saturation point, if we are adding the more amount of sugar, then the extra sugar will not dissolve in this solution. It is settled down in the bottom. So that is called supersaturation. This is called supersaturation. So I think you all are clear that what is the meaning of unsaturated, saturated and supersaturated solution. Now the ionic product uh, in this saturated solution, or when solution becomes saturated, then in the saturation point the product of ions is called solubility product, that is called KSP. And in the if the solution is unsaturated, then the product of ions is simply called ionic product. But at the saturation point, this ionic product is called KSP, means solubility product. And in the supersaturation, it is also called ionic product. But only at the saturation point, the ionic product is called solubility product, that is KSP. So we can say that KSP is obtained only at only in saturated solution. So on the basis of this KSP, we can classify the cation. Now, how we can classify the cation on the KSP? Since in the identification of cation, we are making a precipitate of each cation. Now, we are discussing what are the conditions for making the precipitate. On the basis of these three solutions, that is unsaturated, saturated and supersaturated, we can say that for the formation of precipitate, it's a compulsory that ionic product is greater than solubility product, that is KSP. Since we all know that when ionic product is greater than KSP, then that situation is called supersaturation. And in the supersaturation state, the solute settle down in the bottom, that is called precipitate forms. So, following of this criteria, we are classifying the cation into 7 groups. Now, by the following of solubility product criteria and ionic product, we are classifying the cation into 7 groups. So, start from 0 group. So, first we are drawing a table. First one is called group. First one is a group, and we are selecting a group reagent for each group, that is called group reagent. And third one is which types of radicals, that is basic radicals, are placed on that particular group. So third is basic radicals. Now fourth is composition and color of the PPT. Composition and color of PPT precipitate. Now start from the first is called 0 group. We are having group reagent of this group sodium hydroxide, that is NaOH, or calcium hydroxide. Now the radicals which will be placed in this group, that is ammonium NH4 plus. Its name is ammonium. And in this group there is no formation of PPT. In this group ammonia gas is evolved and NH3 gas evolved. In the first group the reagent is dilute HCl, and the first group we are having the cation, that is silver Ag plus. Next is mercurous Hg2 plus, and third one is Pb plus 2. So these three cations are placed in the first group. Now its composition becomes AgCl, and color of the PPT becomes white. The second is Hg2Cl2, mercurous chloride, and its color also white. Mercurous chloride, it is white in color. And third one is PbCl2, lead chloride, it is also white in color. So that is complete description of group first radicals. Now we are taking the group second radicals. In the group second, the group agent is H2S gas, H2S gas in presence of dilute HCl. And the second group divided into subgroups, two subgroups, subgroup A and subgroup B. In the subgroup A, we are having the cations, that is mercuric, Hg 2 plus and Pb 2 plus, copper plus 2, cadmium plus 2 and bismuth plus 3. These 5 cations are placed in the second A group. Its composition is in the second group, if Hg, then it forms the composition is HgS. Its PPT black in color. Next is PbS, also black in color. Third is copper sulfide, CuS, is also black in color. In the third, fourth is CdS, its color becomes yellow. The PPT of the CdS is yellow, its color yellow. The last is bismuth sulfide, its PPT becomes dark brown. So these are the radicals and its compositions and their compositions that will be placed in the second A group. Now the cations of second A group all are insoluble in YS, that is yellow ammonium sulfide, insoluble in YAS, that is yellow ammonium sulfide, and its formula becomes NH4 whole twice as X. Now we are having the second B group. In the second B group, the represent same, that is H2S in presence of dilute HCl, but we are placing the different cations, group B and H2S gas in presence of dilute HCl, group B, and the cation in this group will be placed, that is arsenic As3 plus, it forms the PPT arsenic sulfide As2S3, and the color of this PPT becomes yellow. Now the second radical of this second B group is, that is antimony Sp plus 3, Sp plus 3, and it forms the PPT Sp2S3, and its color becomes orange. Now the third radical that is placed in this group is tin, that is Sn plus 2. It forms the PPT stannous sulfide, SNS, its color becomes brown. Next radical is Sn plus 4. It forms the PPT SNS2. Its color becomes yellow. Cation of second B group is soluble in YS. Now we are taking the group third. In the group third, the group reagent is NH4OH in presence of NH4Cl. And the basic radicals that will be placed in this group is iron, that is Fe plus 3, aluminium, that is Al plus 3, and chromium Cr plus 3. Now the composition and color of this group. The iron forms ferric hydroxide. It forms a red-brown precipitate. The color of this precipitate is red-brown. The aluminum trihydroxide AlOH whole thrice. It forms a white gelatinous PPT. And chromium trihydroxide, it forms a green PPT. Now, after completing the third group, we will discuss about fourth group. In the fourth group, the group reagent is H2S in presence of NH4OH. H2S in presence of NH4OH and NH4Cl. And the radical in this group comes zinc, Zn2 plus, manganese, Mn2 plus, cobalt, Co plus 2 and nickel, Na plus 2. And the Zn form, Zn is zinc sulfide, its color becomes dirty white. The second one is MnS, its color becomes buff color or light pink color. Light pink is also called buff color or skin color. Third one is cobalt sulfide and fourth one is nickel sulfide. Both are black in color. This is the fourth group. Now we will discuss about fifth and sixth group. In the fifth group, the radical becomes barium, Ba2 plus strontium. In the fifth group, first we discuss group reagent. In the fifth group, the group reagent is ammonium carbonate. In presence of NH4OH. And the radical placed in this group, that is barium, Ba2 plus strontium, Sr plus 2 and calcium, that is Ca plus 2. It will form the PPT of barium carbonate. Its color is white. The second is strontium carbonate. It's also white. And third is calcium carbonate. Its color also white. Now we will discuss about sixth group. In the sixth group, the group reagent is disodium hydrogen phosphate in presence of NH4OH. In the sixth group, we are placing the radical H, magnesium 2 plus. It forms magnesium ammonium phosphate. Magnesium ammonium phosphate. Its color becomes white. So these are the different precipitate and their composition, group radicals, and the next section we will discuss in the detail one by one.